A mysterious visitor is speeding through our solar system, and rumours are spreading fast. Some claim 3i Atlas shows strange heat signals, unusual activity, or even signs of alien life. NASA and scientists raced to study every detail from its tail to its chemistry to uncover the truth. Could this interstellar comet hide secrets we never imagined, or is it simply a natural cosmic traveller? Scientists discovered 3i Atlas on July 1st, 2025, when the Atlas telescope in Chile noticed a faint and fast-moving object. Atlas works under NASA and watches the sky for objects that move in strange ways. Very soon, experts saw that this object travelled extremely fast, reaching about 137,000 miles per hour. Moreover, its curved path showed a hyperbolic orbit, which proved it came from outside our solar system. Because of this, scientists confirmed it as the third known interstellar object ever discovered. The object received the name 3i Atlas, where the number shows its discovery order and the letter means interstellar. It passed closest to the Sun on October 30th, 2025, at about 1.4 astronomical units. Earth stayed far away at nearly 1.8 astronomical units, keeping everything safe. Later, Hubble observations suggested a solid core ranging from hundreds of meters to several kilometers wide, which allowed it to form a bright coma and tail. Scientists around the world joined together to study 3i Atlas as it traveled through the solar system. But do you know that NASA led a massive observation effort using more than 20 missions and observatories working at the same time? What unseen secret could demand the attention of so many eyes across space at once? Space telescopes like Hubble, James Webb, Swift, and Sphere-X watched from Earth orbit, while ground surveys scanned the sky below. Moreover, probes near the Sun and spacecraft around Mars also joined the effort, creating a full solar system view. In early October 2025, the comet passed close to Mars, reaching about 19 million miles away. The Mars Reconnaissance Orbiter used its high-rise camera and captured a bright fuzzy shape from far distance. At the same time, the MAVEN spacecraft recorded glowing hydrogen light caused by heated water vapor. Even the Perseverance rover on the Martian surface spotted a faint streak in the sky. How often does humanity get such a close look at a visitor from another star system? Later, Hubble recorded dust activity far from the Sun, while James Webb studied the comet chemistry in deep detail. Near the Sun, SOHO, Stereo, and Punch followed its movement. Parker's solar probe added side-angle images during the Sun crossing. On Earth, ALMA and Vera Rubin Observatory tracked motion changes caused by escaping gas, giving scientists rare insight into alien material. As 3i Atlas moved closer to the Sun, heat began changing its surface and surrounding space. But that's not all. This glowing transformation is what makes comets like 3i Atlas so mesmerizing to scientists and skywatchers alike. Like many comets, it formed a glowing coma made of gas and dust, along with a long tail stretching behind it. Hubble images from July showed a bright cloud and tail growing stronger under sunlight. Moreover, the tail always pointed away from the Sun, which showed that sunlight controlled the activity. Careful measurements revealed that the comet released between 6 and 60 kilograms of dust each second. Now that amount equals the mass of a small car leaving the comet every few minutes. Even far from the Sun, this activity showed strong ice heating. Scientists also studied the light coming from the comet to learn its makeup. Infrared and spectral data revealed water, carbon monoxide, and extremely large amounts of carbon dioxide. But do you know why this discovery made scientists pause and look closer? Observations from the James Webb telescope showed a rich and uneven gas cloud filled with water ice and flowing gases that stood out clearly against the dark of space. The ratio of carbon dioxide compared to water ranked among the highest ever seen in any comet. This unusual balance suggests the object formed in a very cold region or experienced long exposure to cosmic radiation in another star system. Infrared readings matched normal ice heating behavior throughout every observation. Web maps showed bright carbon dioxide glow exactly where scientists expected it. Then a deeper question quietly formed among researchers and viewers alike. If everything looks normal, why did this visitor capture so much attention? Experts explained that all known interstellar visitors so far show natural comet signals, and 3I Atlas followed the same pattern with very strong carbon dioxide activity. However, as 3I Atlas travelled closer to the Sun, scientists noticed tiny changes in its path. Comets often shift slightly because gas escaping their surface creates a gentle push. Analysts at NASA's Jet Propulsion Laboratory reported that this object showed a small extra acceleration near its closest solar approach. Why did its motion increase beyond what gravity alone usually causes? Researchers explained this behavior through strong outgassing from the comet's surface. Studies led by Avi Loeb suggest that losing a large portion of surface material could create the measured movement. As ice turned into gas, the released material acted like a steady force, pushing the comet forward. And NASA also explained that heating near the Sun regularly creates this effect in active comets. Further observations revealed a rotating jet spraying from the surface. But did you know this tiny wobble could tell the story of the comet's spin and inner structure? Images from the Teide telescope showed a repeating wobble that revealed a spin lasting about 15 hours. This steady pattern matched a natural ice body reacting to sunlight. Scientists described 3I Atlas as a remarkably typical interstellar comet driven by solar heating. As news about 3I Atlas spread worldwide, online speculation grew faster than the science itself. Social media posts and videos began calling the object alive or guided by hidden beings. Some creators claimed strange heat signals, pulsing cores, and unusual energy sources inside the comet. These dramatic ideas moved quickly across forums and video platforms, building excitement and confusion among viewers. However, professional observations told a calm and grounded story. Every telescope and spacecraft recorded behavior matching a natural comet. Experts explained that the orbit, movement, dust tail, and gas release followed patterns seen many times before. Detailed studies showed frozen gases, rocky material, and sunlight-driven activity throughout the coma. Astronomers explained that all recorded signals aligned with known comet physics. Much of the speculation grew after public discussions encouraged open scientific curiosity. Some comments about careful checks slowly turned into exaggerated headlines across the internet. How did cautious scientific questions become dramatic claims so quickly? Later studies revealed expected explanations, including gas effects that can shift color or motion. Careful research continued to support a natural interstellar visitor passing calmly through the solar system. After a short pause in government activity, NASA held a live press briefing on November the 19th, 2025. The goal focused on sharing fresh images and guiding public understanding. Early in the event, Associate Administrator Amit Kshatriya spoke clearly and directly to viewers. He explained that the object shows every trait scientists expect from a comet. Its shape, motion, and behavior all matched long-studied comet patterns. He added that its interstellar origin brings great scientific value and a learning opportunity. During the same briefing, NASA science leader Nikki Fox discussed search results in detail. She explained that every dataset collected showed natural signals tied to ice, gas, and dust. What fascinated everyone was how these ordinary signals could still reveal secrets from another star system. Observations from multiple spacecraft revealed activity driven by sunlight and heating near the Sun. Scientists also explained that the object follows a safe path far from Earth and other planets. NASA released new images during the broadcast from several missions. Viewers saw animated views from Punch showing the object passing Mars. Images from Mars orbiters and solar probes also appeared, showing a bright coma and flowing tail. After the event, NASA updated public pages explaining gas release effects and recent telescope findings. Across every platform, NASA delivered a consistent message describing a natural interstellar comet studied through modern science. Scientists from the Breakthrough Listen project studied 3I Atlas with strong focus and care. Their team used powerful radio telescopes and optical systems across several continents. Over many months, they searched for unusual radio tones or laser flashes coming from the object. What would it mean if artificial signals appeared during these scans? Each observation instead revealed signals tied to natural comet activity. Water molecules, breaking apart under sunlight, produced clear and expected chemical lines. This moment mattered more than many people realized because it tested the biggest rumours head-on. Researchers also measured signal strength limits, similar to everyday human devices at that great distance. Every result aligned with known physics and long-studied comet science. These careful searches added strong confidence that the object behaves like a natural icy visitor travelling through space. Many well-known astronomers shared clear views about 3I Atlas after months of study. Professor Brian Cox explained that every observation fits a classic comet pattern seen many times before. He spoke openly against dramatic headlines and said the object behaves like a normal ice body moving through space. NASA scientist Tom Statler also described 3I Atlas as an extremely typical comet. He pointed to steady jets, regular rotation, and motion driven by sunlight heating. He added that its chemical makeup suggests formation inside an ancient star system filled with radiation. Could these quiet chemical clues be telling a story billions of years older than our own solar system? Harvard researcher Avi Loeb offered a more cautious voice in public discussions. He encouraged careful checks of unusual features and supported deeper analysis using powerful telescopes. At the same time, his own research showed that strong gas release explains both the acceleration and blue color. He described curiosity as healthy during discovery. Across the scientific community, agreement formed around a single conclusion. Radiation exposure and cosmic processing explain the chemistry, supporting a natural interstellar comet passing through our solar system. If you enjoyed learning about 3I Atlas and its interstellar journey, make sure to like this video, subscribe for more cosmic discoveries, and share it with friends who love space. Every click helps us bring more exciting, real science stories straight to your screen.